So the alternating series test is if you have a series that alternates between positive and negative, so you have a u sub 1 minus a u sub 2 plus a u sub 3 minus a u sub 4, that will converge if all of the following three conditions are met. If the u sub n is positive, if the u sub n greater than or equal to the u sub n plus 1. So if the u sub n greater than or equal to the u sub n plus 1, that would mean that the next term is smaller than the previous term, so the terms are actually getting smaller. And when terms are getting smaller, that would be thinking about the series is actually decreasing. And whenever a function is decreasing, you're looking at the derivative is less than 0. And the third condition is if the limit as n approaches infinity of the u sub n term is equal to 0. So even though the terms are alternating between positive and negative, the terms are actually headed towards 0. So in the first example, we'll use the alternate series test. We have the series n is equal to 2 to infinity, negative 1 to the n over 1 over ln of n. So the first condition you have to look at is the u sub n term, and the u sub n term is 1 over natural log of n. And 1 over natural log of n is greater than 0 as long as n is between 2 and infinity. So u sub n is greater than 0, and the first condition is met. The second thing is taking a look at 1 over the natural log of n. And is 1 over natural log of n going to be greater than 1 over the natural log of n plus 1? So is the u sub n term going to be greater than the u sub n plus 1 term? Well, since we know that the natural log of n plus 1 is greater than the natural log of n, so I'm divide both sides by natural log of n. To get the natural log of n plus 1 over the natural log of n is greater than 1. Then dividing both sides by the natural log of n plus 1. We can see algebraically then that 1 over the natural log of n is greater than 1 over the natural log of n plus 1. So the u sub n term is greater than the u sub n plus 1 term. So the second condition is met. Now checking the third condition is the limit as n approaches infinity of 1 over the natural log of n, the u sub n term. That's equal to 1 over infinity, which is equal to 0. So the limit as n approaches infinity of the u sub n term is equal to 0. Since all three conditions then are met, that means that the series from n is equal to 2 to infinity of negative 1 to the n over 1 over natural log of n will converge. For the second example, looking at the series negative 1 to the n over the square root of n, again conducting the alternating series test. The first condition, taking a look at the u sub n term, which is 1 over the square root of n, that is positive for n between 1 and infinity. So the u sub n term is greater than 0. The first condition is met. So the second condition, just take a look at the 1 over the square root of n. Is that bigger than 1 over square root of n plus 1? So if we let f of x equal to 1 over the square root of x, which is really x to the negative 1/2, and take the derivative, we get negative 1/2 x to the negative 3/2. And that derivative will be less than 0 or negative as long as x is between 1 and infinity. So that means that f of x is decreasing. So when the derivative is negative, the function is decreasing. So then that means that the u sub n term will be greater than the u sub n plus 1 term. So then the third condition, which is take a look at the limit as n approaches infinity of 1 over the square root of n, the u sub n term, we get 1 over infinity was equal to 0. So our limit as n approaches infinity of u sub n is equal to 0. So the third condition is met. Therefore, the series from n is equal to 1 to infinity of negative 1 to the n over the square root of n converges.